In this video, we're going to talk about how to calculate the missing side length of a triangle, and we're going to go through many different examples, starting from the easy ones to the much harder ones. So let's start with this example. What we have is a right triangle, and we have two sides of the right triangle. To find the missing side, we could use something called the Pythagorean Theorem, which states that a squared plus b squared is equal to c squared. Now, which of these numbers represent A, which one is B, which one is C? C is the longest of the three sides. It's the hypotenuse. It's across the 90-degree angle. So C is 10. Now for the other two, it doesn't really matter what you make them. So we could set A to 6 and we can make X equal to B. So let's replace A with 6, B with X, and C with 10. So now at this point, all we need to do is solve for the missing variable. 6 squared is 6 times 6, which is 36. 10 squared is 10 times 10, which is 100. Now to get x squared by itself, we need to subtract both sides by 36. 100 minus 36 is 64. Now to calculate the value of x, we need to take the square root of both sides. The square root of x squared is x. The square root of 64 is 8. So this is the missing side of the triangle. It's 8 units long. Now let's try another example. Kind of similar, but a little different. So we're still going to have a right triangle, and the hypotenuse will be 16 units long, and one of the legs of the triangle is 9 units long. What is the other length of the triangle? Feel free to pause the video if you want to try this. So let's say that A is 9, B is equal to X, and C, the hypotenuse, that's going to be 16. So let's begin by writing the formula. A squared plus B squared is equal to C squared. So replacing A with 9, B with X, and C with 16, this is what we now have. 9 squared, that's 9 times 9, that's 81. 16 times 16, that's 256. Subtracting both sides by 81, we have 256 minus 81, which is 175. And just like before, we're going to take the square root of both sides. Now the issue is 175 is not a perfect square. So what do we do at this point? Well, we need to simplify this radical. We need to find a perfect square that goes into 175. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. The reason for that is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. The perfect square that we need though is 25, because we can rewrite 175 as 25 times 7. 7 quarters is $1.75. Now the square root of 25 is 5. So this is the final the final answer in its exact form. So x is equal to 5 square root 7. Now let's try a different example. So we're still going to have a right triangle, but this time, instead of given two sides of the right triangle, we're given one side and an angle. And we need to find one of the legs of the triangle. In this case, what do you think we need to do here? Well, we can't use the Pythagorean theorem because we need to know at least two sides of the triangle. In this case, we need to use trig. There's something called SOH CAH TOA. For those of you who haven't seen this expression before, the SOH part tells you that sine is sine of the angle theta. In this case, theta would be 30. Sine of the angle is equal to the side that's opposite to it. X is opposite to 30, but let's write it as opposite, divided by hypotenuse. So sine is basically a ratio of two sides of a right triangle. The CAH part in SOH CAH TOA is the cosine ratio. Cosine of the angle is equal to the adjacent side of the right triangle divided by the hypotenuse. So A is for adjacent, H is for hypotenuse. Now for the tangent ratio, tangent theta is equal to the opposite side divided by the adjacent side. Now, looking at the triangle that we have, which one of these trig ratios do we need to use? Sine, cosine, or tangent? So first we need to focus on the angle. Opposite to the angle is x, and we know that the hypotenuse is 50. So we have the opposite side and the hypotenuse side. Therefore, we need to use the sine ratio. So sine of the angle 30 is equal to the opposite side, which is x, divided by the hypotenuse, which is 50. Now, to calculate the value of sine, you could use a calculator. You could use the 30, 60, 90 triangle. But to keep things simple, use a calculator and make sure it's in degree mode, not in radian mode. Sine of 30 is, whoops, my calculator is in radian mode. I gotta put it in degree mode. Sine 30 is 1/2. Now let's cross multiply. So we have 2 times x, which is 2x, and that's equal to 1 times 50. Now to get x by itself, we need to divide both sides by 2. So x is 50 divided by 2, which is 25. So that is the missing side length in this problem. So let's try another similar example in which we'll have to use a different trig ratio. So keep in mind, these work if you have a right triangle. So let's say this time the angle is 60, this is 100, and this is x. Which trig ratio do we need to use? The only side that we're missing is the hypotenuse. We don't know the hypotenuse. Opposite to 60 is 100, so that's the opposite side. The other side has to be the adjacent side. So think of SOH CAH TOA, OA, opposite, adjacent. So we need to use tangent. Tangent of the angle being 60 degrees, is equal to the opposite side, which is 100, divided by the adjacent side, which is x. So now, you need to use a calculator to calculate tangent 60. Tangent 60 is equal to the square root of 3. If you don't have a calculator that will give you the exact answer, you're going to get 1.732 something something. But it helps to know that tangent is root 3, which I'm going to write as root 3 over 1. Now we need to cross multiply. So 1 times 100 is 100, and then we have the square root of 3 times x. To get x by itself, divide both sides by the square root of 3. So x is equal to 100 divided by the square root of 3. Now we have a radical on the denominator of the fraction, which most teachers don't like to have it there, so we need to rationalize the denominator. We can do that by multiplying the bottom and the top by the square root of 3. So we're going to have 100 square root 3, and 3 times 3 is 9. The square root of 9 is 3. So this is the final answer. X is equal to 100 square root 3 over 3. Now let's move on to our next example. So this time, we no longer have a right triangle. We have 2 angles, one side, and we need to calculate the missing side. How do we do this? For a situation like this, you need to use something called the Law of Sines. First, identify the 3 angles. We're going to call this angle A, angle B, and angle C. So the capital letters are used to identify the angles. The lowercase letters are used to identify the sides. Across angle A is side A. Across angle B is side B. And across angle C is side C. So we'll use lowercase letters for the sides. Now here's the formula for the law of sines. Sine of angle A divided by side A is equal to sine of angle B divided by side B, and that's equal to sine of angle C divided by side C. Now, we don't have the angle C, nor do we have side C, so we really don't need to use that formula, or that portion of the equation. So we're going to focus on this part. Sine A over A is equal to sine B over B. So we know that angle A is 50 degrees. Side A is what we're looking for, that's x. Angle B is 40 degrees. Side B is 10. So let's cross multiply. This is going to be x times sine of 40 degrees, and that's equal to 10 times sine of 50 degrees. So next we need to divide by sine 40. And now we'll get the answer. So 10 times sine 50 divided by sine 40 is equal to 11.9175. Or we can just say approximately 11.9. So that is the length of x, or side A. So that's how you can calculate it given that situation. Now let's look at another example. So we're going to have a triangle that is not a right triangle, but this time we're going to have an angle. We're going to have two sides and the included angle. And we want to find the side across the angle. In this case, we can't use law of sines. Notice that we have angle A, but we don't know side A, nor do we have any other angles. So for this situation, we need to use something called the law of cosines. And here's the formula. C squared is equal to A squared plus B squared minus 2AB cosine of angle C. Now for this problem, it might be wise to rearrange the letters. We want this to be angle C, so that x is side C. And it doesn't matter what the other two angles are. So C is x. So we're looking for x. That means that A in this example is 9, B is 10. So this is going to be 9 squared plus 10 squared minus 2 times 9 times 10, and then times cosine of the angle C. That's cosine of 30. So 9 squared is 81, 10 squared is 100, and then 9 times 10 is 90, times 2, that's 180. And then cosine 30. Cosine 30 is equal to the square root of 3 divided by 2, or 0.8660254. So now let's do the algebra. So 81 plus 100 is 181. And 180 divided by 2 is 90. So we have 90 square root 3. And let's type this in. 181 minus 90 square root 3. That is 25.11542732. So now let's take the square root of both sides to get the value of x. So x is equal to 5.01. At least that's the rounded answer. So that's how you can calculate the missing side of the triangle if you know two sides and the included angle. You could use the law of cosines. By the way, note what happens if this was 90 degrees. If that was 90 degrees, we would have a shape that looks like this. We would have a right triangle. And let's say this is angle C, angle A, angle B. So then this would be 10, this is still 9, this is still B, this is still A, and then this is C. So angle C is 90. Now looking at this formula, cosine 90 is equal to 0 if you type that in your calculator. So because cosine 90 is equal to 0, this portion becomes 0. So that basically disappears. And then we get the Pythagorean Theorem, which can be used when you have a right triangle. So you get c squared is equal to a squared plus b squared. That's why you can only use this if angle C is 90, or if you have a right triangle. If you don't have a right triangle, then you could use the law of sines or the law of cosines. Now consider this composite triangle that we have here. What would you do in order to find the missing side lengths x and y? Feel free to pause the video if you want to give this problem a shot. So what we need to do is write some equations. We have two missing variables and we need at least two equations to solve it. So the first equation that we could use has to do with the first triangle that we have here. And we could use the tangent ratio. Tangent of 30, think of SOH CAH TOA, the TOA part. Tangent is opposite over adjacent. Tangent, well, opposite to 30 is x. Adjacent to it is y. And this is the hypotenuse, which we don't need to worry about it. So tangent 30 is equal to the opposite side being x over the adjacent side y. That's our first equation. Now, tangent 30, if you plug that in, that's equal to the square root of 3 over 3. So let's cross multiply. So we have y times root 3 is equal to 3x. And let's get x by itself. So if we divide both sides by 3, we get this. X is equal to the square root of 3 over 3 times y. So now we know x in terms of y. Now, what I'm going to focus on is the larger part of the triangle. So let's redraw it. So for the larger part of the triangle, this is x. We still have a right triangle, and the base of that triangle is the sum of these two. It's 100 plus y, and the angle is 20. Relative to the angle 20, this is opposite to it, and this is adjacent to it. So once again, we need to use the tangent ratio. Tangent of 20 is equal to x over 100 plus y. Now, let's type in tan 20. Tangent 20 is 0.36397. And let's cross multiply. So this is 1 times x, which is x, and that's equal to 0.36397 times 100 plus y. So now at this point, we have two equations and two variables. We could solve by elimination or by substitution. So at this point, it's best to solve by substitution, since we have x in terms of y. We can replace this x with the square root of 3 over 3 times y. And this will allow us to get one equation in terms of one variable, which means we can now solve for that variable. So let's begin by distributing this value to 100 and to y. So 100 times 0.36397, you just need to move the decimal 2 units to the right, and you'll get 36.397. And then plus 0.36397 times y. Now, I'm going to move this number over here. The square root of 3 divided by 3 is 0.57735, and then times y. Moving this to the other side, it will switch from positive to negative. And that's equal to 36.397. So 0.57735 minus 0.36397 gives us 0.21338y. Now, we need to divide both sides by 0.21338 to get y by itself. So y is going to be 36.397 divided by 0.21338. And so y is 170.57. So now that we know what y is, we can plug in here to get x. So if you multiply y by root 3 divided by 3, you'll get that x is 98.48. So that's how you can calculate the missing sides of this composite triangle. Now here's another example. What is the value of x for this particular triangle? So notice that all three triangles that you can draw in this picture are right triangles. We have the first one, where this is x, that's 32, that's a triangle. We have another one on the left where this is x, that's 8, and then the larger triangle with the hypotenuse here, where this is 40. So how can we calculate x for this particular situation? Whenever you have a situation like this where the altitude goes to the hypotenuse, x is simply the geometric mean of 8 and 32. So it's the square root of 8 and 32. 32 is 8 times 4. 8 times 8 is 64. The square root of 64 is 8, the square root of 4 is 2, and so the geometric mean of 8 and 32 is 16. Now let's think about this. Why is 16 the geometric mean of 8 and 32? Well, if you multiply 8 by 2, you get 16. And if you multiply 16 by 2, you get 32. That's why 16 is the geometric mean between 8 and 32. If you have a geometric sequence, 16 will be in the middle of 8 and 32. Now let's consider another example. So let's say that this side is 8, this is 18, and this is x. And we also have z and y. How can we find x, y, and z? Feel free to pause the video and work on this problem. So we know how to calculate x. X is the geometric mean between 18 and 8. So 18 is 9 times 2. And then we could break it up into the square root of 9, and 8 times 2 is 16. The square root of 9 is 3, the square root of 16 is 4. So we know that x is equal to 12. So once we have the value of x, we can calculate the values of y and z. So notice that y is the hypotenuse of this triangle. So we could use the Pythagorean theorem. A squared plus b squared is equal to c squared. So a would be 18, x would be b, x is 12, and y is c. Eighteen squared is 324. 12 squared is 144. So adding those two together, that gives us 468. So now we got to take the square root of both sides. Now 468 is divisible by 169. Actually, I take that back. It's divisible by 36. 468 is 36 times 13. And the square root of 36 is 6. So y is equal to 6 root 13. Now let's calculate z. So we're going to use this right triangle. Let me use a different color. And notice that z is the hypotenuse of that right triangle. So we're going to have a squared plus b squared equals c squared. Let's make a equal to 8. B is going to be x, which x is 12. And c is z. So 8 squared is 64, 12 squared is 144. And 64 plus 144, that's 208. So now we got to take the square root of both sides. 208 is divisible by 16. If you divide 208 by 16, you get 13. And the square root of 16 is 4. So it helps to find the highest perfect square that goes into this number. And then you can simplify the radical. For those of you who want more examples on simplifying radicals, just type in simplifying radicals organic chemistry tutor, and I will explain into more detail how to do that. So this is the answer for z. Now, notice that this problem becomes relatively easy to solve if you know that x is the geometric mean of 18 and 8. But let's say you didn't know that. How would you solve this problem? It turns out that just by knowing the Pythagorean theorem, you can calculate the value of x. Let's talk about how to do that. So note that we have three different variables, x, y, and z. In order to solve this equation, or to solve this problem, we need three equations to solve for three variables. So let's write those three equations. Let's start with this triangle. So we could say that 18 squared plus x squared is equal to y squared. Now moving on to this triangle, we see that z is the hypotenuse. So we could say that 8 squared plus x squared is equal to z squared. Next, we could focus on the larger triangle, which is also a right triangle. And this time, the hypotenuse is the sum of 18 and 8, or 26. So we could say that y squared plus z squared is equal to 26 squared. Let's call this equation 1, equation 2, and equation 3. So what I'm going to do is I'm going to subtract equation 1 by equation 2. So I'm going to rewrite equation 1. And then I'm going to multiply equation 2 by negative 1. So this would be a negative 8 squared minus x squared equal negative z squared. Next, I'm going to add these two equations. Notice that x squared will cancel. So I get 18 squared minus 8 squared is equal to y squared minus z squared. So now I can combine this new equation with equation 3. So I'm going to write it below equation 3. Y squared minus z squared is equal to 18 squared minus 8 squared. So combining those two equations, notice that the z squared variable cancels. Y squared plus y squared is 2y squared, and that's going to equal, we can add this up, 26 squared plus 18 squared minus 8 squared. Now let's plug in the numbers. 26 squared, that's 676. 18 squared is 324. 8 squared is 64. 676 plus 324 minus 64, that's 936. Dividing both sides by 2, we can see that y squared is half of 936, or 468, a very familiar answer. And then once we take the square root of both sides, we know that the square root of 468 is 6 root 13. So we have the value of y. Now we can calculate the value of x. And let's use equation 1 to do that. So let's move 18 squared to the other side. X squared is y squared minus 18 squared. Now we know that y squared is the square of this number, which is 468. And 18 squared is 324. So 468 minus 324 is 144. Taking the square root of both sides, we can confirm that x is equal to 12. That's the square root of 144. So now that we have x, we can calculate z using this formula. So 8 squared is 64. X squared is 12 squared, which is 144. 64 plus 144 is 208. And we know that the square root of 208 is 4 root 13. And so that's how you can get these answers without knowing that x is the geometric mean of 18 and 8. It's by writing 3 Pythagorean theorem equations for the 3 right triangles, and then using algebra to solve for the 3 missing variables. So that's it for this video. Now you know many different ways to calculate the missing side of a triangle. Thanks for watching.